Hi, today we're going to see how to test a VR board, that is ATMEGA 16 or 32 board. Before I start testing a VR board, I make sure that I'm getting the proper voltage from my transformer. So I connect the multimeter across the secondary of my transformer and I'm getting 13.5. Of course, I have set this multimeter on 200 volt AC. Okay, so we are getting around 13.5 volt. This is sufficient for my application. So I shall start testing my AVR board. Okay, you just connect the transformer secondary to the board at this points. Okay, so the LED is glowing. That means what? I'm getting the power supply. Okay, the board is getting the power supply. That is absolutely clear. Okay, what is next? Next we have the 1N4007. These are the rectifier diodes. Okay, whose PIV rating is 1000 volt. Okay, so I have to make sure that whether my rectifier is working or not. Okay, so before that, this is my 7805 and it has a hole through it which is nothing but my ground. You put a black probe of your multimeter, that is nothing but ground, in that hole so that it will be connected to the ground, and you take this positive or a red probe of your multimeter and you connect to the cathode of the first 1N4007 or the first diode. Okay, so you are getting around 38 volt, but we are not measuring the AC. You have to set this on a DC. Okay, now you set this on a DC, again you connect, we are getting the 17 volt. Okay, this is my rectified output. The same voltage you will be getting at this point, because this is nothing but my rectifier output. You may be having a question that why we need the rectifier output in this manner. We may need or we may use this rectifier output to drive the variety of the DC motors or the relays or the loads which needs more than 5 volt. Okay, now what else we are supposed to test? You put a common terminal in a hole of a 7805 and you check output of 7805. This line is my output of 7805. Okay, so this is my output line. Okay, as soon I connect this multimeters here, the probes of the multimeters here, I get 5 volt. Okay, see, I'm getting 4.9. that means what? I'm getting the proper 5 volt. This 7805 is functioning. Okay, this middle one is a ground and this is my rectifier output, as already we have seen. Okay, so rectifier output is 17 volt. This is my ground and here we are getting the 5 volt. So you must be thinking why we have put a number of buck strips or multiple VCC and grounds. So the reason behind this is very simple, that we may have to connect a different variety of the sensors, devices, processors or controllers, okay, which may be demanding a 5 volt so that we can connect all the devices to this power supply through the 5 volt. We have made provision for multiple 5 volts. Okay, so this is my 5 mm LED. Okay, this is for the power on indication, so that we can easily make out whether my board is getting the power supply or not. Okay, and we shall check what is the drop across the LED when it is in on state. I shall connect the multimeter here. Okay, we are getting 1.87 volt. That is nothing but 1.8 volt. This is nothing but drop across the LED when it is in on state. We have put a 470 ohm resistor. This is current controlling resistor, and we have supplied this LED with a 5 volt, and we can see that the drop across the LED is 1.8 volt. Okay, so already we have gone through the calculation that the drop across the LED is going to range from 1.8 to 2.5 volt depending on the supply voltage that we provide to the LED. Okay, it may be ranging from 1.8 to 2.5. In my case, it is 1.8 volt drop. This is the on voltage drop across the LED when it is in on state. Okay, so this is about the power supply. Next, we should go for the testing of ATMEGA 32 or ATMEGA 16 board. Okay, we shall test this part of the board. Okay, and this is my LCD. This is a female buck strip, the provision for the LCD, and this is my preset which is used to control the contrast of my LCD. Now you can put the LCD in this slot. Okay, the backlight is on. Okay, and if I vary this preset, you may see that there is a change in contrast of my LCD. Okay, this is the simple testing how we can test the LCD. Okay, this is my preset used to control the contrast of my LCD. Now we shall test the rest part of the ATMEGA 32 or 16. Before we start testing this, we should know few points. Okay. Now this is a pinout of my ATMEGA 32 or a 16. Both are having the same pin configuration. So very first I have to make sure that where is the reset. Reset is pin number 9. Reset bar, that means it is active low. Okay. So normally it is connected to the VCC through the 10K register. This is called as a pull-up register. Okay. This register can be varying from 10K to 40K, and I think this is recommended by the manufacturer. It has to be less than 40 ohm. Okay. And this is a reset switch. Okay. So if I press this, the 0 potential will be applied to the reset, that is pin number 9. Okay. It will apply 0 volt to the pin number 9. Okay, now the microcontroller will be reset since it is active low. Okay, if I release this button, that will be again connected to the VCC through the 10K register. Okay, so this is all about the testing of 9. Now next we should have the VCC, that is 5 volt at pin number 10, and we should have a ground at pin number 11. This is useful for the microcontroller internal operation. On opposite side we have 30, which is connected to the AVCC, that is a 5 volt again, and this is a 5 volt connected to the internal ADC of my AVR. This is pin number 31 connected to ground. Okay, this has to be connected to the ground. This is again used for the internal ADC. Here we have a reference. This is again connected to the VCC 5 volt. This is nothing but a reference voltage of my internal ADC, that is pin number 32. Okay, we shall test this on my board now. You put a common terminal of your multimeter in a hole of 7805, and you connect the positive terminal to the pin number 9. Here I should get 5 volt. We are getting 4.85, that is approximately 5 volt. As soon I press this switch, we should get 0 volt. We are getting it. That means now the microcontroller is reset. Okay, it will execute the program from the beginning. Okay, as soon as I release, again it is connected to the VCC through the 10K register. Here we have the 10K register. Now next we should have the pin number 10, that should be connected to the VCC. This is pin number 10 and this is 11. Here again I should have the 5 volt. Yes, we are getting the 5 volt. Okay, next we should have the pin number 30 connected to the 5 volt and 31 to the ground. So this is my 30 and this is my 31. I should get here a okay, I'm getting the 5 volt. Okay, this is pin number 30, red terminal connected to the 30 and 31 is connected to the ground, and here we are getting the 5 volt. Okay, now on a 32, on pin number 32 also we should have the 5 volt, that is analog reference, ADC reference. Okay, we are getting the 5 volt. That means what, my board is getting is functioning properly with the reset. It is having the VCC ground and ground analog VCC analog reference voltage. Okay, so this is ready to work. Okay, this is all about the testing of my AVR board.